the chemical formulas correctly, you must have the chemical symbols correct in your fingertips. So you should know, if you're talking about potassium, you should know that the chemical symbol for potassium is K. If I am talking about sodium, you should know it is Na. So the chemical symbols of any element you want to deal with, you must know it. The second thing you must have in your fingertips is the valence electrons. This the valence of the element you are talking about. And that's what I want to take you through, how to determine the valence of an atom. And the other third thing I think you must have is the elements in the first 20 elements in the periodic table. So you need to master. You should know that the first one is hydrogen, helium, downwards to calcium, number 20. So valence electrons are very, very critical in writing chemical formulas. Valence electrons are very important. Therefore, we want to define what a valence electron is. What is a valence? This is the number of electrons an atom loses or gains during a chemical reaction. Valence electrons are also called combining power, because this is what we use to combine atoms to form a compound. Combining power. Here I have a table that contains the first 20 elements, atomic number 1 to atomic number 20. I have the name of the element, the symbol of the element, the number of protons, electrons, and electron arrangement. We call it electron configuration. So the reason why I have this is that I want to show you how to get the valence of an atom, of an element. The valence. That is very important for you to know. First, as I have said, you must know that atomic number 1, we have hydrogen. Atomic number 2, we have helium. Atomic number 3, radium. Number 4, beryllium. 5, boron, carbon, nitrogen. Atomic number 8 is oxygen. Atomic number 9 is fluorine. Atomic number 10 is neon. 11 is sodium. Magnesium, number 12. Atomic number 13 is aluminium. Silicon is atomic number 14. Phosphorus is atomic number 15. Sulfur is atomic number 16. Chlorine, argon, potassium, and finally calcium, atomic number 20. Calcium. When you know the atomic number of an element, you automatically know the number of protons present. You automatically know the number of electrons present. As you can see, atomic number is equal to protons and electrons. So just get n atomic number 17. Atomic number 17 is chlorine. It means it has 17 protons and 17 electrons. Very important. So when we are writing electron configuration, if I pick 17 chlorine, I want to write electron configuration. I know that chlorine has 17, is atomic number 17. Therefore, it has 17 protons, 17 electrons. So when we are writing electron configuration, we are writing the electrons in the first energy level, second and third energy level. So chlorine has 1, 2, 3 energy levels. So you must make sure that this one will sum up to 17. 2 plus 8, 10. 10 plus 7 is 17. So we have two types of electron configuration. We have the duplet and the octet. So those elements like this, like helium, it has only electron configuration of 2. This one we call it a duplet, 2. But the rest, to be stable, they must have an octet. This one is called octet. This one is called octet, electron stability, octet. Very good. So what is the importance of electron configuration? Writing electron. If now I want to know the valence of carbon, I will get the electrons in the outermost electrons, and then I ask myself, carbon is not stable because it must have a stability of 2 or 8 288 or 28. If sulfur is atomic number 16, atomic number 16, 16 protons, 16 electrons, electron configuration is 2 to 8 to 6. How will it react? How does sulfur become stable? Sulfur has, we consider the electrons in the outermost energy levels, the outermost energy level. So sulfur has 6 electrons in the outermost energy level. So what will happen? Will it lose 6 electrons to be stable, or it will regain 2 to be stable? It is easier to gain 2 electrons, so plus 2, it will regain to have a stability of 288. It will regain 2, and it will become negatively charged sulfur. It will become negatively charged. When an element gains electrons, it becomes negatively charged, and when it loses electrons, it becomes positively charged. So what is the valence of sulfur? Is 2. So whenever you see sulfur, sulfur has a valence of 2. Calcium. Calcium is atomic number 20. It has 20 protons, 20 electrons. So when these electrons are written in the energy levels, the first energy level always starts with 2 electrons. So 8, 8, and then 2. This is 20. Look at what will happen. So 2 to 8 to 8 to 2. This is the electron configuration of calcium. So during a chemical reaction, this one is not stable. Calcium is not stable. Therefore, it will react by losing 2 electrons. Gaining 6, for it to have the stability of 2888, requires a lot of energy to gain. Therefore, it requires less amount of energy to lose 2. Therefore, it loses the 2 electrons and it becomes calcium 2 positive. So, these electrons that are lost from an element or gained is what we call the valence electrons, and very important in writing chemical equations and balancing. Very good. So what I'm saying is that you must know the atomic number of an element. Once you have the atomic number of the element, you write electron configuration, and you shall be able to know the valence of that electron. Suppose I want to know the valence of aluminium. Aluminium is atomic number 13. Yes, aluminium, I know it is atomic number 13. Therefore, 13 is 2 to 8 to 3. This is 2, 10, 13. Atomic number, electrons, 13. Therefore, what will happen? Aluminium will react by losing 3 electrons to be stable. It will not gain 5. It will require a lot of energy to gain 5 to be stable. But it will require less amount of energy to lose 3, and then the ion, which is now aluminium ion, 3 positive, will have a net charge of positive. And this one is aluminium ions. So generally metals react by losing electrons, and non-metals react by gaining electrons. That is the general trend. So hoping that you have understood how to get the valence of an electron, now we can go ahead and talk about the elements which are not in the periodic table. So what about those elements which are not in the periodic table? We have few of them. We have elements such as zinc, that is commonly used and is not in the first 20 elements. We have copper, we have barium, we have lithium is not majorly used, so I want to debate the ones that are commonly used. Iron, we have iron 2, most compounds have iron 2. Which else? Zinc, copper, lead, very good, lead. So these 1, 2, 3, 4, 5 are commonly used. And what is the valence of this? You realize that all of them, they have a valence of 2. So zinc has a valence of 2, copper has a valence of 2, barium has a valence of 2, iron has a valence of 2, although we have iron 3. We have iron 2 and iron 3. But most compounds of iron, we have iron 2. Unless you are told. Lead is valence 2. So all of these, they have a valence of 2. They lose only 2 electrons to be stable because they are metals. So this should not be a problem. Whenever you say zinc, remember zinc has a valence of 2. Copper has a valence 2. Barium has a valence of 2. Iron a valence of 2. Lead a valence of 2. The next very important basic information I want you to have is about radicals. We have radicals which are used to form salts, which are combined with metals to form salts and other compounds. Therefore, we need to understand what a radical is and the valence electrons of each radical. What is a radical? Or radicals are these are groups of atoms with a net charge that exists and reacts as a unit during a chemical reaction. You don't need to the definition, you can, but I want you to concentrate on the valence of each radical, valence electron. So we have those radicals in valence that have a valence of 1. We have the radicals that have a valence of 2 and the radicals that have valence of 3. But I don't think you have seen very many chemical reactions dealing with phosphorus. So this one is not commonly used. We want to deal with the commonly used. We have salts, carbonates, magnesium carbonate, zinc carbonate, magnesium sulfate, zinc sulfate. We have sulfites, sodium sulfite. We have the sulfites. So these are the commonly used radicals. We have the nitrates, magnesium nitrate, potassium nitrate. We have there. We have sodium hydroxide, calcium hydroxide. We have ammonium carbonate, ammonium sulfate. So the ammonium ion has got a valence of 1. So whenever you are using ammonia, remember it is valence 1. This one you must diagram, you must understand, you must read them regularly. Read it twice, thrice, 4 times, and these things shall get into your system. So once you know that hydroxide ion has got a valence of 1, nitrate ion has got a valence of 1, hydrogen carbonate has got a valence of 1, hydrogen sulfate has got a valence of 1, -1, then you will be able to see the way we are going. This one is very helpful in writing chemical equations or formulas. Carbonates has a valence of 2. That one, get it like that, master it like that. Sulfates have a valence of 2. What did I say? Carbonates have a valence of 2. Sulfates have a valence of 2. Sulfite has a valence of 2. Very important. So now when we come writing chemical formulas, you are going to find out how important the valence of radicals and other elements is in writing chemical formulas. So let us go straight now to writing chemicals. Formulas, chemical formulas. So we want to write chemical formulas. We have so, for example, when elements combine, for example, sodium can combine with chlorine to form sodium chloride. So sodium plus chlorine will form sodium chloride, right? And this is now a compound, sodium chloride compound. So this reaction how will you if you didn't know how to write sodium chloride, I don't think it is going to be easy for you to balance. So before this, we are talking about chemical formulas. I'm writing equation. I don't want to go there. So sodium chloride is a chemical formula for sodium chloride salt. Why? Let me write another one. If I write here magnesium chloride, I'm going to put it to here. But these two, I didn't put it for chlorine, for sodium chloride. But for magnesium chloride, I have a 2 here. So why did I do that? I know that magnesium is atomic number 12, electron configuration 2 to 8 to 2. Therefore, how does it react? It reacts by losing 2 electrons, so it has a valence of 2. Chlorine. Chloride ion is atomic number 17. Chlorine is atomic number 17. It has electron configuration of 2 to 8 to 8 to 7. Electron configuration of 2 to 8 to 7, yes. So during chemical reaction, what happens? It reacts by gaining 1 electron. Therefore, the valence of chlorine is -1. We don't write -1, we just write -1, negative. So 7 has shown me that the valence of chlorine is 1. So therefore, let me write 1 here, up here. So what happens during a chemical reaction? They interchange the valence electrons. So this one comes here 1, and this one comes here. And so therefore we have magnesium 1, chloride 2. But pick 1, we don't put it like there. We assume it is there, but we just remove it. Therefore, the final product we have is magnesium chloride. And that's why magnesium chloride is written with 2, and this one is not. So let us see why sodium chloride, there is no 2 here. Sodium chloride is atomic number 11. So sodium is atomic number 11. Electron configuration 2 to 8 to 1. Chlorine, we have said, is atomic number 17. Electron configuration 2, 8, 7. How does sodium react? Sodium reacts by losing 1 electron to be stable because it cannot gain 7. Therefore, it loses 1 to form sodium ion positive. Chlorine, electron configuration 2, 8, 7, react by gaining 1. So if it gains 1, it becomes negatively charged. So negative, positive combine to form sodium chloride. So both of them, as you can see, they have a valence of 1, 1. So when we are talking about a valence, we don't care whether it is negative or positive. Valence, if it is 1, it is 1, not negative or positive. So sodium, valence 1, chlorine, valence 1. So they interchange 1. So they do like this. So 1, 1. So 1, 1 is like this, not there, or it cancels out. Therefore, sodium chloride. So this is the chemical formula of sodium chloride, and this is the chemical formula of magnesium chloride. Zinc nitrate, zinc sulfate. These are salts. So zinc sulfate is written like this, zinc nitrate is written like this. So let me first talk about the nitrate, and then zinc nitrate, and then sodium nitrate before I come to sulfates. Let me talk about nitrates. Nitrate, we know, is a radical. Nitrate is a radical, valence 1. Therefore, it means that this here, it has a valence of 1, right? Zinc, I have told you that metals which are not in the periodic table, all of them, they have a valence of 2. So don't think twice. Zinc, lead, copper, iron, take them to have a valence of 2. So it means this zinc has a valence of 2. So what will happen? They will interchange, cross multiply. So this one will come here, 2, and this one will come here, 1. So the final, let me read this, we will have zinc nitrate. Because this one we cannot put 2 here, we put a bracket to differentiate this one so that we cannot confuse, and we have 2. And this one is called zinc nitrate. So let me write zinc or potassium nitrate. Potassium nitrate is KNO3. That is potassium nitrate. Do you realize I don't have a bracket here? I don't have a bracket. Why don't we have a bracket there? We know that potassium is atomic number 19, electron configuration 2881, therefore it has a valence of 1. A nitrate, we know it has a valence of 1, which is negative. but we have told you for variance we don't care whether it is negative, it is 1 1. So what will happen is that this one will bring 1 here and this one will bring 1 here. So 1 1 is like it is not there, and therefore the chemical formula for potassium nitrate is KNO3, as simple as that. But if it is magnesium nitrate, so if you write magnesium nitrate like this and leave it like that, you will be wrong. You have not considered the valence electrons of each of them. Magnesium is atomic number 12. Atomic number 12. So electron configuration 2 to 8 to 2. And nitrate has a valence of 1. That one you must master. Nitrate has valence 1. So what happens? So magnesium is valence 2. Nitrate is valence 1. So 1, 2. So therefore the final magnesium nitrate is MgNO3 bracket 2, and this is the correct formula for magnesium nitrate. Magnesium nitrate. So we have a nitrite and a nitrate. So when it is 3, it is nitrate. Nitrate rate. When it is 2 here, when we have 2 here, it is called nitrite. Let me come to sulfates. Zinc sulfate. Remember the sulfate has a valence of 2. The sulfate has a valence of 2. Zinc has a valence of 2. So you put 2 here, put 2 here. So you cross multiply, we have 2. You cross multiply, we have a bracket, and then we have 2. So these 2 and these 2 cancels out, and then the final chemical formula for zinc sulfate is ZnSO4. Like that. So what about zinc nitrate? Sodium sulfate. Sodium sulfate. Sodium sulfate, if you write like this, you will be very wrong. You will be very wrong. Sodium sulfate, so the sulfate itself here has a valence of 2. The sodium is atomic number 11, 281. Therefore, it has a valence of 1. So this one transfers 1 here, and this one brings 2 here. So the chemical symbol for sodium sulfate is Na2SO4, and this is sodium sulfate. You can see it is different from zinc sulfate. Zinc sulfate does not have 2 here. It doesn't have anything there. Therefore, valence electrons are very important in balancing equations. The next one, let us talk about the carbonate. Sodium carbonate. If you write like this, you will be very wrong, because the carbonate has a valence of 2. Sodium has a valence of 1. So when it interchange, this one happens. So sodium will have 2, and the carbonate will be like this. This one is sodium carbonate. Yeah, so what about the calcium carbonate? Calcium is atomic number 20. Carbonate. Atomic number 20, it has a valence of 2. The carbonate has a valence of 2. So 2, 2, put 2 here, put a bracket, put 2 here. So these 2 and these 2 cancels out. So therefore, the final calcium carbonate chemical formula is calcium carbonate. So once you have known these things, writing and balancing chemical equations will be very, very easy once you have understood what we have dealt with. The next one is ammonium ion. So ammonium ion is valence 1. Ammonium ion has got a valence 1. So if I want ammonium nitrate, we will have ammonium nitrate. This one has a valence of 1. Nitrate has a valence of 1. Therefore, the correct chemical formula for ammonium nitrate is just like this. Ammonium nitrate. And this is very correct for ammonium nitrate. It is fine. But what if I wanted to write ammonium sulfate or ammonium carbonate? So ammonium carbonate, I know the carbonate has a valence of 2. I know this nitrate, the ammonium has a valence of 1. Whether it is positive or negative, it doesn't matter. the thing is 1 or 2 or 3, the variance. So what happens, this one they will exchange. Because there is 4 here, we must have a bracket here to put it 2 here. This 1 will come here 1. 1 has no effect, therefore the correct chemical formula for ammonium carbonate is NH4 bracket 2CO3. That is the correct chemical formula for ammonium carbonate. Ammonium sulfate is the same, like this. So ammonium sulfate is H4 bracket 2 sulfate. Because the sulfate has a valence of 2, ammonia has a valence of 1, ammonium ion has a valence of 1, so no, like that. Suppose I wanted to write aluminium oxide. Is this the correct chemical formula for aluminium oxide? You would be right. You have aluminium, you have oxygen, so that's an oxide of aluminium. But now, once you have written aluminium oxide, you want to write aluminium like this, you want to write aluminium oxide. Once you have written like this, now you ask yourself, what is the valence of aluminium? What is the valence of oxygen? So you already know that aluminium is atomic number 13, 2 to 8 to 3, so the valence is 3. You know that oxygen is atomic number 8. So the electron configuration is 2 to 6, so it will regain 2 electrons, so the valence is 2. So when now you have aluminium 3, oxygen 2, what happens is that this one will bring 2 here, and this one will bring 3 here. Therefore, aluminium oxide is 2 oxygen 3. And this is the correct formula of aluminium oxide. Suppose I want to write aluminium sulfate. Aluminium sulfate, if you write like this, initially you are fine, you are okay. This is aluminium sulfate. Now the only thing is that you have not asked yourself, what is the valence of the sulfate? What is the valence of aluminium? Aluminium is valence 3. We have said that. The sulfate is valence 2, right? So what happens is that aluminium, the sulfate, they interchange. This one comes here, 3, and this one comes to here, 2. So the correct formula for aluminium sulfate is aluminium 2 sulfate, and then you put a bracket there, 3, and this is the 4. Aluminium sulfate is written as that. Thank you. Let us meet in the